Hey guys, gonna record a little video here about wave interference. So what happens when two waves hit each other? So here we have a little animation. Two waves are coming in towards the middle, and boom, they hit each other. Now what happened here? Did they bounce off of each other? Did they pass through each other? Well, which one? So let's take another look here. We'll change it up a little bit, and we'll show a video of a real thing. So over here, look, we make two pulses. Here we have one. And you can see the two pulses continue on the other side. So they pass through each other. Again, two pulses here. The single pulse goes off to the right, and the two pulses continue off to the left there. So this is called interference when these two waves hit each other. Interference is when waves overlap. Their effects may be increased, decreased, or neutralized entirely here. And this follows something called the superposition principle, which just means you put them on top of each other. So the simple way to say the superposition principle is you simply add up the amplitudes of the two waves, and that is the amplitude of the wave that you would see at that moment that they're overlapping. So let me give you an example here. Let's say you have the red wave coming into the right, amplitude of 1 whatever, and the blue wave coming into the left, amplitude of 1. And so when they overlap each other, one from the blue wave and one from the red wave, they would add up and make an even bigger crest right here with an amplitude of 2. So what you would actually see is the green wave there. You wouldn't see the blue wave or the red wave while they were overlapping. You would see the green wave. And we call this constructive interference. So when a crest overlaps a crest or a trough overlaps a trough, their effects will add together to give us a bigger amplitude. And we call this constructive interference. So again, here is an amplitude of -1 from the red wave, -1 from the blue wave. When they get together, we get an amplitude of -2, which is what we would see. So this is also constructive interference. A lot of people think crest on top of crest is destructive, and trough on top of trough is, crest on top of crest is constructive, and trough on top of trough is destructive, but they're both constructive because they make a bigger amplitude. So what is destructive then? Well, let's look at this example. Red wave has an amplitude of +1. Blue wave has an amplitude of -1. So when they got on top of each other, according to the superposition principle, you add their amplitudes. 1 plus -1 gives you 0. So when a crest overlaps a trough, they subtract from each other, and this is what gives us destructive interference. So here's just a little animation again of that past one. So what you would actually see is the green wave there. So you would see the red and blue pulses until they got over top of each other. And then you would see the pulse act as the green one. Notice for a moment in time, it's perfectly flat right there as they pass through each other. So they've totally destroyed each other. And this works for any type of wave. This works for waves on a string, sound waves, light waves. They can all do this. And they don't have to totally destroy each other to be destructive interference, just at least partially destroy each other. So here's one more animation. In this case, this is a green wave traveling to the left, a blue wave traveling to the right, and you can see sometimes like now and now and now, they're constructively interfering with each other and making what you would see as the black wave even bigger than before. But sometimes like right now and now and now, they're doing destructive interference because crests are overlining troughs and they're destroying the wave for that moment in time. Oops, I'm trying to figure out how to end the video here. So